Mechanical Engineering Division and recognized and an approved CPD program of IA, contributing to the continuous professional development of our members. We are truly privileged. Today we have with us eminent panelist Mr. Alexander Sodeski, founder of Alsodo, Germany, who brings a rich international experience and practical insights into the use of FreeCAD in real-world mechanical design applications. I am confident that these sessions will highly informative and inspiring. I would like to also acknowledge the valuable efforts of South Gujarat Local Center, Chairman Engineer Ketan Panchal, organizing team, and our moderator Himanshu Bhatt for their dedications in making this technical program possible. Also, thanks to the Dr. King Sung, without whose supports this webinar is not possible. I'm encourage all the participants to actively engage in today's session and make the best use of these learning opportunities and explore how open source tools can effectively integrated into our professional practice. With this word, I once again welcome all of you and wish the webinar great success. Thank you and have an enriching technical session ahead. Over to you.
Thank you, sir, for your kind words of wisdom. May I now request Engineer Himanshu Bhatt, the moderator of the session, and also is the honorary secretary, South Gujarat Local Center, to have a few words regarding the theme of the webinar and please introduce the panelists of the session. Sir, please.
Yeah, good afternoon, all. I would just wait for a moment. I would share my screen. So, is my screen visible?
Yes, sir.
Yes, it is visible.
Yes. So, good afternoon once again, and thank you all participants for joining on this webinar. I would first like to thank this Institution of Engineers India for providing us this platform. And through South Gujarat Local Center, we are conducting this webinar under the Mechanical Engineering Division with a guidance and support from Mr. Dr. Neelaj Kumar for this arranging this session, and Kinshuk Sen sir for providing all the supports and creating the links for the session. So thank you all. We will start with the first. I would brief you what we are going to talk about and how the idea came to conduct this series of webinar. So I'm running my own consultancy services in mechanical design, and many a times we interact with many clients, and we feel that we are too much depending on the commercial softwares, but at the same time it is not only the commercial software, but it is the freedom behind the software. We many times come across a situation, particularly as an engineer, that somewhere something is missing, which we should be able to modify, but we don't have the freedom to modify because the software is not open source. So, what is open source software? How it can benefit to us as an engineer? We feel that there is a gap and this needs to be addressed. So with this things in mind, we proposed to conduct this webinar, and our South Gujarat local chapter chairman Ketan Kumar, Dr. Ketan Panchal sir immediately appreciated this, and then we put forward a proposal to Institution of Engineers India headquarters, and it was approved. So today we are here, and I would now start with the presentation of the first point, where we will talk about what is open source. And in the second part, Mr. Alexander Sadowski will take over and take us through the mechanical engineering workflow. So I'm Himanshu Bhatt. I'm a secretary at IEI South Gujarat Local Center. I'm also founder of Maxwell Design LLP, where we are exploring and implementing open source tools at this my own startup. And now we are helping others, our clients and other community, to take the same benefit through Maxwell OSS. This QR code is my link profile of LinkedIn. So those who are interested in more details can connect on this. You can scan the QR code and connect to me on the LinkedIn. So let's take a moment to think and understand what is open source. So many a times when we talk about open source, we feel that it is a free software. So let's understand what is free software and what is open source. So when we are working in a with something open source, we will come across this terminologies. One is free as speech or free as beer and open source. So the distinction is the freedom. When free as speech means you have a freedom to modify and share the contents at your wish. Whereas free as beer means somebody gives you beer as free. You can't do anything with that, but just drink it. So just consume, just use it. So when the software is available just for use, you can't do anything, you can modify, you can review the source code, then it is, even if it is a free software, it is not an open source software. So the philosophy of open source software is this source code is available publicly, and there is a collaborative development efforts going on those software where the code is available in community. People can review the code, inspect the code, modify as their wish, and republish this modified code back to the community. So that is open source. So the difference between what is free and open source, now we can say that it is possible that a free software is not open source, and it is also possible that a open source software is not free. But today, in today's world, many projects that we are reviewing are both free and open source. So it is called FOSS, free open source software. So I think up to this point, everyone is clear. So let's move to next point. Uh, Software history, this I have prepared not to bore you all with the timelines and all, but just to understand that open source is not something new. It has very old roots. When the computer development started in the early years of 1950s and 1960s, the coding, the software for the computers used to be generated through academic and research collaboration, and it always used to be freely available along with the hardware and with the source code. But during the period of 1970s and 1980s, there was a surge in requirement of computers and its relevant software, and industry realized that there is a huge potential to commercialize the software, and that is how the rise of proprietary software began. And it's not only that rise of proprietary software began, but they started to restrict the access to its source code. So this was a point when somebody named Richard Stallman came and said that I need to have access to my software even if I'm purchasing, or it should be free. So he started something called Free Software Foundation with General Public License GNU, and later on it was transferred to all the Linux development, and the era started of open source software. So this is open source is not something new. This slide is just to consider that open source has very old roots and it is not something new, but it has limited awareness. So we are talking on this. So let's come to our main question. What is open source? By now, we have understood that open source software has its source code available publicly. So when the source code is available publicly, anyone can study, modify, and redistribute it under specific licenses related to open source. The example of such softwares are Linux, Python, many of us would have heard, Firefox browser that is open source, a database, PostgreSQL, FreeCAD. We can list hundreds of softwares which are available in open source category. Now, to explain this open source with an engineering analogy, we can take an example of a sealed machine. If you buy a machine which comes sealed just for the purpose of usage, it is something called closed machine. You do not have access to open the machine, you do not have access to read the drawings of that machine, do any modification. No, it is built for a purpose and it will only serve the purpose. Whether you get it free or purchase is irrelevant. Whereas the open source terminology makes that machine available openly with full drawings and ability to modify. So when you have a machine which has its all detailed GA drawing, fabrication drawing, etc., if you are putting up a plant, what would you prefer? A sealed machine or a machine with all the drawings and the details? Obviously, we will look for the machine which comes with all the drawings and details, right? So this is the benefit of open source. So open source is not just a free software, it is a freedom to modify, a freedom to adjust it to our requirements. I hope I'm making the point clear here. Okay. So when we talked about redistribution, there are some licenses. I'll just quickly go through that. It can be a permissive license where you can modify the code and sell it further. There can be a copyleft license where you can modify the code and put it back to the open source, or there can be dual licensing. But for today's our webinar focus is on using of the software, not developing of the software. So these licensing terms are applicable to the persons who are developing open source software and modifying it. As a user, we just have to understand the terms that these things exist, but we don't need to worry at all about any of these things. The software is open source, available to you. You can start using from day one. So are the open source software reliable? Can we rely on open source software? From the participants, if anybody would like to share something on this question before we move forward, what is your view? Have you heard of open source, or do you think open source softwares can be reliable? Are you using that? You can you can give me answers on the chat box. I'll wait for 1 minute to get some answers. Okay, let's move forward. So, before answering this, I would like to show you some statistics. Like, you are already using open source software every day. Your Android operating system is based on Linux, which is open source. Today's internet, more than 90% of the internet sites are on Linux server, which is open source. You use the cloud database, those are open source based on Linux backbone. So these Linux key statistics I have taken from the Linux website, and it says that Linux is dominating the market when it comes to servers and the cloud infrastructure. If open source is not reliable, this would not have happened, right? So, so this is to prove that open source are reliable, and similar reliability are also available in the engineering domain. That is what we are going to focus in our webinar series, and that is where so okay. So that is where we will be focusing on that which engineering tools are available in open source domain, how we can use that reliably and confidently. I have this one last slide before we move forward that again shows that even in the era of AI, this is very recent publication in 2025 by Linux Foundation. The study says that over 80% of the leads in the proprietary approach are in the sovereign AI on open source. So you can, I'm not going in all these statistics, but the AI development which is into happening in today's era, majority of the things are on open source. So open source has already proved its reliability. Now it's only up to us and the awareness that we can use the software to our benefit for the future. So if all things are good about open source, why we are not using open source in engineering? What are the struggles? So Dr. APJ Abdul Kalam in his 2010 speech at Vision for Free Software Movement had highlighted the importance of free software. But it has not been widely used even today because of these three reasons, which I think. The three reasons are: first is limited awareness, because many capable softwares and tools remain underutilized due to lack of visibility. Commercial softwares, there are business development managers, marketing team, they keep calling to engineering institutions, industries, and selling their software, making the demonstration, etc. For open source software, there is nobody because it is a community software. So you have to find out your own required tool. That is awareness. Second is learning curve. The initial setup and workflow of the software, how it is to be operated, remains a challenge for the beginners. And support is not centralized. Like if you have a commercial software, you have a sales team which has given you some commitments, you can 24 by 7 call them, hey, this is not working, fix it, and they have to respond. When it is open source, you have the source code, you are responsible how you manage your software. Obviously there is a team of community working behind it. There are multiple forums where you can put your questions, but it's all voluntary. People will come there and answer. You have to wait. So these are few terms, things where I found that open source software implementation is having some limitation and struggles, and this is where we are trying to break the constraint, and we want to move forward with the open source software usage in industry. So now I will introduce our next speaker, Mr. Alexander Sadowski. He is founder of Alsado, a German-based company. He is also an author of book FreeCAD Beginner's Handbook. He has recently published, and this book has multiple examples on FreeCAD software, and all the examples also Mr. Alexander has very generously published on GitHub as a free open source again. So he has been delivering expert talk and presentation on complete mechanical design workflow using various open source tools, including FreeCAD, on multiple international platforms. So this is his QR code to link to his LinkedIn profile. You can scan this link and connect with Mr. Alexander. And now I'll hand over to Mr. Alexander Sadowski. Over to you, sir.
Thank you very much, Himanshu, for your kind introduction. And also thank you very much for taking the initiative to arrange this FreeCAD talk with the Institution of Engineers. So also thank you very much for the Institution of Engineers for organizing this event and spreading the word about open source software in engineering, and more specifically, which we will take a look at today, is FreeCAD. So let me just share the screen so that I can show you what we will be talking about. Can you hear me well?
Sorry. Yeah, but sorry to interrupt. We have some message on our Q&A session. Mr. Kinshuk Sen, people are responding that chat is disabled. I request if you can enable the chat so that if there is some interaction to be done, we can take care of that. Yeah, now we can proceed.
Good. So thank you very much, Himanshu, for the introduction. Today I will show to you how FreeCAD can be used for your design process in mechanical engineering. And more specifically, this is how product development process can look like in engineering usually. And we have already shown in the past that it is possible to implement the entire product development process using fully open source software like LibreOffice, FreeCAD, PrePomax, and many others. But today we will focus on the detailed design part of this whole process, and we will show how you can go from the sketch to the 3D printed prototype, all in open source software, mainly FreeCAD. So whenever you design your machine, your robot, or any other product, you create your sketches, then you create your CAD design, and then you first create your or manufacture your prototype, and later on you then manufacture your product in series. And today we will take a look at what is FreeCAD. So FreeCAD is a complete 3D CAD software that small to medium-sized enterprises in manufacturing can integrate today, and they can use that for their design process and to prepare all their parts and assemblies for manufacturing. With FreeCAD, you have got a universal interface, which means that it supports all the industry standard formats, which are STEP, DXF, STL, 3MF, or PDF. So STEP would be used for 3D CAD files. DXF would much rather be used for 2D files, which are then loaded by CNC laser cutting machines or water cutting machines. And STL and 3MF are formats for 3D printing. Like just recently, the free MF format was introduced, which is an improvement on STL, but most people still know about STL. FreeCAD is built up in a kind of framework where it is modular in its nature, and this was inspired by CATIA V5 back then when FreeCAD project was started. The FreeCAD project was started around 2000, so it's nearly over 25 years old already. And over all of those years, FreeCAD has developed more and more. And I would say like 5 to 10 years ago, it crossed a threshold where it is actually usable for productive work. So what are all of those modules that can be that are available in FreeCAD? The most important ones for mechanical engineering, which we will also take a look at today, are the part design workbench, which is used to design your parts, the A2 Plus workbench, which is used to create assemblies. In the newest FreeCAD version, there is actually a newer assembly workbench, but we will still take a look at the previous one because we have been working with that and we have validated it for our projects, and we will also validate the new one in the future, but right now we are still using the A2 Plus workbench. And as far as technical drawings, they can be derived from the CAD files using the TechDraw workbench. And this works like just any other CAD software. You don't have to create the technical drawings from scratch. You derive them from the CAD file. And those three workbenches enable us to design our parts, assemble them into complete assemblies to check if everything fits, and then derive our technical drawings, which will then we can use to send to our manufacturer, or we can manufacture it in-house. And because FreeCAD has a Python API, and which also is displayed in the graphical user interface, you can intuitively understand scripting and automate all of your tasks, like design tasks, drafting tasks inside of FreeCAD using code. And I've already seen some people connect that to an AI to drive the models, and but I am not sure about the reliability at this moment. But still, it's a very interesting future prospect for any developments, and I'm curious about what we can do by combining AI and FreeCAD. And on top of that, because FreeCAD is an open source software and it's not any open source software, it's actually the most popular CAD software worldwide. So it has got a big community where we can go and talk to people, get some help, and just get inspiration from other people's projects through the wiki, through the forum, or on all the social media channels. And all of this, like I said earlier, makes FreeCAD a complete 3D CAD software, which is also extendable. And through the add-on manager, we can get access to many additional add-ons that do very specific things, like the shipbuilding add-on or paraglider add-on. So there is many more functionality that we can get by downloading the additional add-ons. Now let's take a look at the graphical user interface first so that everyone understands what we are looking at. In this example, this was a CAD model of a electric vehicle platform, which we used for crash simulations. But in this case, we will use this example to show what the most important parts of the graphical user interface are. So in the middle, on the right, you have got your 3D view, which you can rotate, zoom in, zoom out, all the things that you know from other CAD software. To the left of that, we've got the document tree, which lists in a hierarchy all of the objects that are inside of our document. These could be different parts, different features, and stuff like that. We've got our workbench selector where we can switch between different workbenches for all the people that know CATIA V5. This is pretty similar to how CATIA V5 behaves. And we've got our toolbars on top where, depending on which workbench selected, the functions there will change. So when we have got the part design workbench selected, the toolbars change to reflect and show only the functions from the part design workbench. And all of this, maybe it looks a bit old or old school, but FreeCAD is actually well structured. You know always know where to find your functions. It can be a bit steep of a steep learning curve at the beginning, but once you know where it is, then it's easy to navigate. And I think those are the most important parts of the graphical user interface. And once you understand that, you can work with FreeCAD effectively. So now let's take a look at first how to create individual parts in FreeCAD. When we create our parts in FreeCAD, we create a document for each part. So we would create a FreeCAD document, which it's abbreviated as FCSTD. This is the native FreeCAD file format. And within that document, we create one body, except for some use cases where we have to create multiple bodies when we want to do Boolean operations. But for most parts, creating one body inside of that document is good enough. And each body has got its own origin, which are the planes and axes of our coordinate system. And how do we create a part? We follow a very specific workflow from part design. So within our body, we either select an existing plane or we create a new datum plane. We then create a sketch on that plane and then use that sketch for a 3D feature like extrude or revolve. And this is the core workflow of how you can create 3D CAD files in FreeCAD. And for all the other people that have experience with other CAD software, they will recognize that pretty much every CAD software works the same way. You have got a plane, you have create a sketch, and you extrude or evolve that. And then in the end, you create all your topology dependent features like fillets, thickness, or shells. Um, Everything that is dependent on topology is done at the end to lower the risk for your parts pretty much this being destroyed, or for the references inside of your part being not referencing correctly anymore. So all in all, FreeCAD is very similar to any other CAD software. For most people, it's just the user interface that gets them distracted from it because it looks old, but at the core, it works very similar to any other CAD software. And on the right, you can see how a document tree would usually look like. And this one shows the document tree of the part that is displayed here. We can see a body, and inside of that body, we've got an origin where this part is located. We have got a datum plane, which was used to create a sketch. And once a sketch is used by a 3D feature, it gets consumed by it, so it cannot be used again by other features. And other CAD, so there are different, some software, they don't consume the sketch, and other software will consume the sketch. So in this case, it gets consumed, but there are ways of how we can maneuver our document tree. So if we don't want it to get consumed, we can prevent that. Once we have got our all of our individual parts in FreeCAD, we can create assemblies using constraints with the A2 Plus workbench. The name may sound a bit weird and very specific, but this has just historical reasons because it's the second assembly workbench plus, which means with some improvements. So there was someone who created the first assembly workbench, then somebody else created a different workbench, different assembly workbench, and then somebody else created an improvement on that. So that's how those names came to be. And also, like for our individual parts, for our assembly, we create separate FreeCAD documents for each assembly and also for each sub-assembly. We import instances of our parts from external FreeCAD documents. That's why it's important to have each part as a separate file. We then constrain our faces and axes of our parts, like for example, constraining two planes or two axes and making them coincident. And we can also move our parts temporarily just in the graphical user interface so that we are able to actually select the face, because sometimes when you put in a new part, they intersect, but so they obstruct you from clicking on the face, and then we can temporarily move them to the side, click on the face that we wanted, and then we can move on with our constraints. And doing that, we can create a multi-level assembly hierarchy with sub-assemblies where each of those sub-assembly is a separate file. And as you can see to the right, here's an example that shows how these constraints are done. You select one face on one part, another face on another part, and then you create the coincident constraints. So all of this is very similar to SolidWorks, Solid Edge, and other CAD software. And this is why this workbench has been quite popular for creating simple assemblies. For assemblies which have thousands of parts, we have to rethink it a little because of performance issues. But for most people, this is good enough. And then once we have our individual parts and also our assemblies, we can derive a technical drawing for manufacturing. And this is done with the TechDraw workbench, which is the third workbench that we will introduce here. And first, we create a drawing page with integrated and editable page templates. All of the page templates are in SVG format, which is a vector graphic format that we can modify on our own using, for example, Inkscape, which is also open source. And this way we can create our custom page templates for our technical drawings. And in this case, I just used a standard one and derived this part as a technical drawing. First, we would rotate our part in the 3D view, like we have seen previously, like shown here. We would rotate it so that it's our main view that we want to be on our drawing. We then go to the drawing and we can place a projection group on that page that we've already created. After that, and after we have placed all the views that we need, we add dimensions like distance, diameter, or radius, and also tolerances like plus minus for each dimension, or separately as tolerances for the entire part that we would do as a page annotation. And after that, we would add edge and surface annotations like roughness, edge break, and many other annotations like defining material treatment, and much more. You can do all of that in FreeCAD with like edge annotations and surface annotations. We have previously, like in the past, developed these so that people can import them into FreeCAD, because in two versions before they weren't available. but right in the current version, all of these have been fully integrated into the Tektro workbench. And once we have created our technical drawing, we can export that as a PDF file so that others don't need FreeCAD to open it. We can export it as PDF and then send it to a manufacturer, or we can manufacture it in-house. And for all the people that want to first create their prototypes before sending it out to big manufacturing, we can export uh, a FreeMF file from FreeCAD from our bodies, which represent our parts. We import those parts into a different open source software, which is called Prusa Slicer. And in Prusa Slicer, we can import all of our parts from FreeCAD, arrange them on the build plate, set all the printing settings like layer height, how fast the printer moves, and other settings. We can slice that and generate the G code that we can then use to transfer it to our printer. And you can see here going from left to right. On the left, we have imported our part. We can very intuitively arrange it on our build platform. For example, when we have got 20 parts of the same, there is even a function to automatically arrange them onto the build platform, which spaces them in irregular distances. So we can have an array of the same part. And doing that, we can quickly manufacture our first prototype of our design with FreeCAD. And in this case, we have also shown the Prusa 3D printer because they have developed the Prusa slicer, but you don't need to have a Prusa 3D printer to use the Prusa slicer. You can use the Prusa slicer with pretty much any 3D printer. And now we will show you a live demo of how we can create one of those parts, going from the finished technical drawing back to the parts, which in this case would be the upper wishbone of our Mars rover that we introduced in the beginning. So let me take over and go to FreeCAD. This is the FreeCAD user interface. And we are greeted with the start screen where we can create files and open files. In this case, I will select the parametric part, and automatically a new file has been created, and in this file a new body has been placed. Within the body, there is an origin object which by default is not visible, but we can select it and then press the spacebar to see all the planes and our axes that we need. So this is the space where we will create our part. And so let's start with our workflow that we have introduced before. So first, we will either select a plane or we will create a new plane. We will then create a sketch on that plane, and we will then use that sketch to create a 3D feature like extruding or revolving. And extruding or revolving can be done either additively or subtractively. In FreeCAD, the additive function for extrusion is called pad, and the subtractive is called pocket. And you can identify them by their icon or symbol color. All the yellow red ones on the left are all the additive, and all the blue red ones are all the subtractive 3D features. So let's start out with our part. We will first create our first cross section. So I will create that on an existing XZ plane from our coordinate system. I have selected the XZ plane in the 3D view. I create a new sketch, and FreeCAD now automatically rotates the view and also constrains all of our input so that the sketch is always done in this plane. So for this part, we have to create a cross section of it, and I know that we need to create a slot. So now with 3 clicks, I have created this whole slot, and now I will constrain it in the sketcher. So I will first constrain these 2 points to be symmetric to the coordinate system axes. Now the sketch turned orange, which means that it is over constrained or there are redundant constraints. This can sometimes happen when, for example, whenever we create geometry, FreeCAD creates some constraints automatically. And when we later on add new constraints, it's possible that that previous ones become redundant. And FreeCAD shows it to us by making the lines orange. In order to fix that, there is in the solver messages, we can see it says redundant constraints. And there is a number, which means 6. I click on that number and FreeCAD automatically selects the redundant constraint. I now just have to press the delete button on my keyboard and it deletes the redundant constraints. And now we have finally placed the symmetric constraint, so whenever I move the right point, the left point also moves. So what is left is constraining the distance between those 2 points. I select those, click on the dimension tool, which in the recent version, it automatically knows what type of dimension we need. Previously, you had to explicitly tell FreeCAD, do I want diameter, radius, length, whatever. In this version, FreeCAD can now determine that on his own, and it knows that we don't need a radius or anything or arc or anything else. We need a distance. So we will define that as 20 millimeters. We will also define the radius to be 6 millimeters. Let me just go back to the drawing because I'm not sure what the exact dimensions were. So we have a distance of actually 30 millimeters, and we have got a diameter. Let me zoom that in for you so we can see better. We are trying to reproduce this cross section. So I have to define 6 millimeters and 30. We can always, because FreeCAD is fully parametric, whenever I have set a parameter, we can always go back and change it later on. And now our drawing should be ready. However, I can see that the FreeCAD selected the diameter because it's not a full circle. So I will define the radius as 3 millimeters here, so it's correct now. I close the sketch, and having the sketch selected still, I click on Pad, which creates an additive extrusion. And in this case, I want it to go symmetrically into both directions. And I want it to be over a width of also 30 millimeters. So I enter 30 millimeter as a dimension. I click OK. And we have got our first solid object created in FreeCAD. This is not our final part, but this is our first solid object. I will now finish the whole part and just quickly move through it because we can't go that much in depth about how this part is created. So I will just do the steps and not explain every one of those. But we create our hole here, which we will also constrain to be 15. Close it, and then we can create this through all symmetric, okay. Then we can mirror this onto the other side, click on OK, and now we have got these parts ready. We can next create the XZ plane. And here we need to define this one. So I have now here defined this line as a construction line, so it will not be part of the geometry. And here I'm taking all the dimensions from the sketch that we have shown earlier. So this should be 4. And whenever we are not sure what constraints are missing, we can just pick any part and drag it to see, okay, I need to still constrain uh, the dimensions as width of this rectangle here. As you can see, I have put in the dimensions for the height as too low, and we can always correct these things. I can go back into the last feature that I've done. Take a look at the sketch. With a double click, I can open it, define a different height here, close it again, and then our part is fixed. Now, maybe we don't need the planes anymore. I can hide them, and we have got our part finished. So this would be our upper wishbone of our Mars rover. And this would be how you would create a part in FreeCAD. And then we can create the technical drawing from that. We can export it for 3D printing. We can include that into the top level assembly and other things like that. And if you want to learn how you can create this whole Mars rover from scratch in FreeCAD, we have recently published a book with Prusa Research, who is a manufacturer of 3D printers. And in this collaboration, we tried to help beginners go from turning their idea that they have put in their head, for getting it into onto a sketch, like something that is tangible, and from there into a 3D printable prototype. And I think that is very important because it allows us to quickly move through development cycles. And thanks to 3D printing, we can much faster develop our products because we can faster assess any problems with it, and we can print our first prototype, take a look at it, hold in our hands and see all the problems, go back to FreeCAD, do the changes, and then print it out again. And this is how you can quickly move forward in developing your new products. Thank you very much for everyone who is here today with us. And thank you again for Himanishu for inviting me to hold this talk on FreeCAD. And together we can move engineering forward, especially with the latest development. Like I've seen that India is very strong now in in the space research. I think like 2 or 3 years ago, there was this big achievement from I cannot remember exactly what the event was, but I just can remember that there was some big achievement like 2 or 3 years ago from the Indian space agency. And yeah, let's see where we can go from there. So I'm giving it back to Himanishu.
Yeah, thank you, Alexander. The event which you are mentioning probably is Chandrayaan 3, which we had launched for the moon, and it was okay. So, great presentation, and nicely you covered the basic workflow of FreeCAD, which resembles to many commercial softwares. So, this software ensures that there's very familiar GUI when we first time open it, and it has very many add-ons where persons from different engineering field, like it has a BIM add-on for architects and civil engineers, then it has a FEA add-on for FE analysis. So multiple things we can do within the software, and it has a very nice rich features in that. Now we can have any questions from any participants. We can take it for 5 minutes and then we can move forward to closing of the session.
Sir, few questions have already arrived in the question answer box, and our
Yeah, so
moderators have already answered a few questions. So,
right. So I'll read it for everyone's benefit. The question is whether the FreeCAD is cloud-based software or offline can operate. So FreeCAD is 100% offline software. It is available for Windows as well as Linux operating system. You can just go to FreeCAD site and download it and start using it. Another question was about can you give one simple part analysis example? So due to time constraint, we just introduced the FreeCAD software, but there is a separate Wiki document. We have shared the link on message box. You can go to there. There are many FEA workbench related examples. You can go and study that and implement it.
Let me just give a note on the FEM workbench in FreeCAD. So there is an FEM workbench in FreeCAD, but if we are doing more complex finite element analysis, we would probably want to use something different, like PrePolMax or Open Radios. I would just use the FreeCAD integrated FEM workbench for very simple ones. But when we want to really gain control over the mesh and the force and everything else, and then we should probably go to PrePolMax, which is based on Calculix or Open Radios.
Okay, great. So for those who are unaware, PrePolMax is another software. It is also an open source software like we are talking about today. The name is P-R-E-P-O Max. The name comes from pre-processing, post-processing, and that is how the software is. It is a very promising software, and as Mr. Alexander rightly pointed out, it has many advanced features as compared to FreeCAD FEM Workbench. So for serious FE analysis, we should consider on that software. In future, if possible, we will try to arrange one more seminar on PrePolMax also.
Yes, sir. Yes, sir.
Fine. So with this, Kinshuk Sensor, shall we proceed to close or we have
We
anything?
are at the fag end of the very interesting session of this webinar series. All participants we are very much expecting all of you to please join tomorrow in our next webinar starting from 8 p.m. IST onwards. And now I request Engineer Himanshu Bhatt sir to please propose a vote of thanks for the day. Thank you.
Yeah, so good evening all again, and I thank Institute of Engineers India for providing this platform, sharing the knowledge and awareness about the open source software. Thank you, Mr. Alexander, for accepting our invite and uh, delivering this very insightful session out of his busy schedule. Thank you, our mechanical team, Bilaj Kumar, for remaining present during the opening session and opening this session with a very good note on open source software, knowledge sharing, etc. I personally thank South Gujarat local chapter for providing me the opportunity and our chairman, Dr. Panchal sir, for accepting and taking forward my proposal. And not the least, all the participants for joining today and making this event successful. I hope you have gained much insights on what is open source and the FreeCAD software usage, and you will be able to use this. I have already shared our contact details. If you find anything that we can be of help, do contact us. Thank you very much.
Thank you also everyone, and yeah, I wish you a great day. Here it is a weekend, so wish you a good weekend and enjoy your time.
Thank you.
Bye.
Thank you, sir. Thank you. Participants, those who want to opt for e-certification, the e-certification link is open till tomorrow midnight for today this webinar. So kindly go through the second link or the second QR code in the flyer and please opt for the e-certificate that is applicable for the CPD hours. Thank you.
Okay, fine. Thank you. Bye bye.
Thank you, sir.